Here is question 19, the final question of paper 2 of the year 11 mock, the question on vectors. This is one that definitely is worth reviewing. Now the question, part A, express FE in terms of A and or B. Well, let's have a look what we have here. CD is A, so I'm going to mark that clearly on the diagram. D to E, which is D to E, is B. Now we do have a midpoint there, so I'm going to mark that a half or 0.5, 0.5B and 0.5B. So that satisfies this. D to E is B. Half a B and then half a B. F to C, this, is A minus B. So let's just mark that there. So if I'm going from F to E, I can say F to E equals, well, A minus B plus A plus B. And what you'll notice is the minus B and the B cancel out, and we have 2A there. So that's part A. Now moving on to part B. What we need to do here is find the ratio of fx to xm in the term n to 1. So let's look back. So that's fx, xm. So in order to do this, we need to express the line fx. And I'm just going to show you how I'm going to do this. So I'm going to start with saying fx is lambda, which is some fraction that we don't know yet, of fm. So lambda of fm. Well, fm is, well, let's have a look, A minus B plus A plus half B. So A and A, that's going to give me 2A minus B plus half a B. Well, that's going to give me minus, let's use decimals there, half B. There we go. You can see that. So that's fx. Now we're told in the question that CXE is a straight line. So that's CXE. So I'm going to draw a straight line to help me there. Now, why this is useful is it gives me another route between f and x. Now that route between f and x can be expressed as saying I'm going to go first from F to C. There we go, FC. I'm moving this around so you can see between the diagram and the working. So that's F to C plus some fraction, and this time I'm going to use mu, another Greek letter, of C E. So what does that mean? It means I'm going to go up here and then part of CE, that fraction is mu. I'm using a Greek letter there to say I don't know how far I'm going, but it's mu distance of that full line. And there we go. Well, let me put that into A's and B's. So fx is fc, which is a minus b, plus mu, and ce I can see is a plus b. I just look at another route to get from c to e, and it's a plus 1b. There we go. So what I have here is two ways to get from f to x, and that really helps me form a simultaneous equation. So let's write these out as equal to each other. I have my first one here, lambda times 2a minus 0.5b is equal to my other fx, which would be a minus b plus mu a plus b. Now that, I suppose, can look a little bit confusing. What we're going to do now is we're going to make a simultaneous equation. So I'm going to count how many a's I have on both sides. Well, let's have a look here. I've got 2 times lambda lots of a's. So I say 2 lambda on this side. On the right hand side, I've got 1a there plus mu lots of a's. So I can say 1 plus mu. I'm going to compare the b's. So here I've got negative 0.5 lambda on the left hand side, and on the right hand side I've got negative 1 b plus 1 mu b there. So this is comparing the amount of a's I've got and then the amount of b's. Well, then we have a simultaneous equation. I'm going to subtract these because then I can eliminate those mu's. If I subtract here 2 lambda minus negative 1/2 lambda, I get 2.5 lambda. There, as you know, the mu's cancel out, and I've got 1 minus negative 1, so I've got 2. So lambda is going to equal 2 over 2.5, or 4/5. Well, why is that useful? Well, what that tells me is if I go back to this relationship here, fx is actually 4/5 of fm. So this line is 4/5 of the whole line. So this bit is 4/5. This is a fifth. That would render the ratio, if we look fx to xm, to be 4:1. So if we go back and read exactly what the question is, fx to xm, n:1. Well, the ratio there is 4:1, so n is 4. So there's quite a lot going on there. Hopefully you've got access to the question to review this. I would recommend taking it away and having another look through and working through the question yourself.